Here I will explain about our project. Our project, The Last Survivor, is a game designed to entertain players with an engaging survival adventure. In the game, the lone survivor wields a gun and navigates forward, searching for others like him. However, instead of allies, he encounters monsters. To survive and move ahead, he must eliminate anything blocking his path.
So here's the explanation about why we made this game. We made this game to play in our spare time. We used a fairly simple design to make it easier for us as a beginner to make it. The game mission itself is also not too difficult, so it's suitable for all age.
For the application design, the game features a background of empty streets and places. The monsters include two types, slime and caterpillar worms, each costing the player 1 life upon contact. As for the controls, players use the spacebar to jump, C to shoot monsters, left and right to move forward and backward, and R to restart the game after losing.
Next, flowchart. The flowchart outlines the gameplay logic for the Last Survivor game. Start. The game begins by executing computer input for the player. Input C, shoot. If the player presses C and hits a monster, the score points. If they do not press C, the code light white with the monster and lost a life. Input spacebar or jump. Pressing the space bar allows the player to jump and avoid monster, scoring points. In the do not press the space bar, they get hit by the monster and lost a life. The game continue until the player lost a life, leading to a game over.
Next, game mission. The mission of this game is that the blue character must kill the enemies on the path he takes. There are two enemies, namely the green and the caterpillar. In order to survive, the blue character uses a gun to kill the two enemies. When we successfully kill the green or the caterpillar, we will get 1 score. We must be able to get as many as possible before the lives we have run out. And a note, every time a blue character fails to kill an enemy, such as being shot or the character hits the enemy directly, they will lose 1 life. When the life runs out, the game ends.
Our challenge in making this game is to determine the game mechanics, such as player control and game objective, and then error in the code such as bugs or crashes when running require time to identify the cause and fix it, and also dividing time between coding, designing character, and testing the game becomes a challenge for us to be able to complete the project on time while ensuring the game to continue run well. Hello everyone, today I'm excited to walk you through a simple game setup using PyGames. First, we import the necessary library. We have PyGame, which is the main library for game development, and exit from the SYS module to close the program and import random to generate random numbers or position. Next, we call pygame.init parentheses. This initializes all the PyGame module we will be using in our game. Then we set up the game window with pygame.display.set underscore mode parentheses 1280, 720 parentheses, which create a window of 1280 pixel wide and 720 pixel tall. We also set the window title to Tugas Project UAS using pygame.display.set underscore caption parentheses. To control the frame rate of our game, we create a clock object with pygame.time.clock parentheses. This will help us manage how fast our game runs. Then we load our background image using pygame.image.load parentheses quotation street.png quotation parenthouse dot convert parenthouse. This image will serve as the initialized background for our game. Then we load the player spread with pemain surface pygame.image.load parenthouse quotation pemain.png quotation parenthouse dot convert underscore alpha parenthouse. The convert underscore alpha parenthouse method allow for transparency in the image. We also set up a gravity variable for the player and define the player's starting position using dot underscore rig parenthouse. And then for setting up health indicator, we load an image for the player's health indicator with nyawa underscore surface pygame.image.load parenthouse quotation nyawa.png dot convert underscore alpha parenthouse. This will visually represent the player's health in the object. Then we load another image for the enemy with hijau surface pygame.image.load parenthouse quotation hijau.png dot convert underscore alpha parenthouse, and we position it using get underscore rig parenthouse. Now we introduce our second enemy is a caterpillar by loading its image with ulat surface pygame.image.load parenthouse quotation ulat.png dot convert underscore alpha parenthouse. We create a list called ulats to store our enemy and add the first enemy and second enemy at a random position on the screen. And then we also prepare for projectiles by loading the fire image with fire underscore surface pygame.image.load parenthouse quotation fire.png dot convert underscore alpha parenthouse. We create a list called fires to keep track of active projectile. Setting up start button. Finally, we load image for the start button. The start button is centered on the screen at coordinate 640, 360, and the start button in position below it at 640, 500. And that's it.
So the restart underscore surface, we put the pygame.image.load and then put the file to load the restart button image, and then the restart underscore reg is to place the button at the center of the screen and at the coordinates 640 and 500. The score starts at 0 and the life start at 4. And then for the score and life font, we put the pygame.font is 60. Game over font, we put the size is 100. And then the restart font, we put the size at 40. And then for the function, first is def update underscore fire for the position of the bullets. For fire underscore in fires, we put here 10 for the speed of the bullets. And then if a bullet goes past the screen's right edge, like when the bullet above the 1270, it remove the bullets from the surface. And then def update underscore ulat, it's for the enemies. For ulat underscore right in ulat, here we put the 5, so the enemies move with a speed of 5 pixels per frame. And then for the return, if an enemy passes the left edge of the screen, like above -100, it's removed from the game display. And here for the ulat spawn, we put the def spawn ulat. There are fewer than 15 enemies on the screen, and then we put the number between 0 and 100 is less than 1, which gives a small chance for a new enemy to appear. And then if the both conditions are true, a new enemy is spawned at a random position on the right side of the screen. And then this is the function def_draw_life. It's for making the picture of the heart of the lives. And then this we put here the 40, so distance between life icon is 40 pixels. Each life icon is displayed starting at 980 on the screen with a distance of 40 pixels between each icon. So the reset game function at def_reset_game, we reset the player's position with the player_rec. So when the players reset, it put the player's position to 600 and 455 at the bottom center. And then we put the fires.clear, bullets.clear, so it clears all bullets and enemies from the screen. And then we add the new enemy at random position also, and we restart the score. We reset the score to 0 and then reset the life to 4 when we restart the game.
Function code for main screen, we use def_start_screen bracket, and then we're gonna put while true for event in pygame.event.get if event.type is equal to pygames.quit, pygame.quit, and then exit. Next is a detections button before we start the game. If event.type is equal to pygame.mouse button down and start_rec call the point event.pause. And then for the return back to main game, we use return. Here we're gonna put start button and playground, so we use screen.bleed open bracket latar_awal_surface, and then we use the same code for start surface, screen.bleed open bracket start_surface, and then start_rec close bracket, and then pygame.display and update brackets, it's for display the screen, and then clock.take 60. Before the game start, we use start_screen for the background, and for looping the game, we use while true for event in pygame.event.get brackets if event.type is equal to pygame_quit, pygame.quit, exit quit. There is 3 buttons to detect. The first one is space button, the second one is C for shot, and then the last one is R for restart. For the space button, we use if event.type is equal to pygame is key down, if event.k is equal to pygame.k_space and player rec button is less than 45. For the second button, it's for shot, so we use C button. If event.k is equal to pygame.k_c and lives more than 0. And then for the new bullet, we use fire_rec equal fire surface get_rec, and then middle left for player rec and mid right, fires.append and fire rec. And then for the last button, we use R for restart. If event.k is equal to pygame.key_r and lives is 0, restart the game.
3. Restart game. Ketika tombol restart di layar diklik, fungsi reset game akan dijalankan untuk memulai ulang game. Kodenya memiliki if sama break. Fungsi restart rec collide point memastikan bahwa pemain mengklik pada tombol restart. 4. Desain antarmuka game over. Saat game over, layar diisi dengan warna hitam ditampilkan tulisan game over, skor akhir, dan tombol restart. Memiliki kode screen fill, game over surface, score surface, screen bleed, dan pgame display update. 5. Pengendalian frame rate. Game menggunakan clock tick 60 detik untuk membatasi kecepatan frame menjadi 60 fps sehingga animasi berjalan halus.
Graffiti logic. Player graffiti plus equals 1. Player rec y plus equals player graffiti. If player rec bottom smaller or equal to 455, this will limit the space player on the ground. Player space. Player rec bottom equals 455. And to renew the bullet position is fires equals updates fires. And to renew the caterpillar position is ulets, update ulets, and spawn ulets. And for the green monsters movement, that will be hijau rec x minus minus equals 4 if hijau rec right bigger or equal than 0, hijau rec left equals 270. And to detect the clash of the bullets and the green monsters, it'll be 4 fire rec in fires. If fire rec collide direct or hijau rec left equals 1270 to reset the green monster's position, and fires removed to remove the bullets that hit the monsters, and score plus equals 1. After that, to detect the clash between the bullets and the caterpillars, 4 fire rec in fires, 4 ulet rec in ulets. If fire rec collide rec ulet rec, ulets remove. This is to erase the caterpillar that has been shot, and fires removed to erase the bullets that hit the caterpillar, and score plus equals 2. The scores for caterpillars are higher than the green monsters. And to detect the clash between players and green monsters, it'll be if player rec collide rec hijau rec left equals 1270 to reset the green monster's position, and lives minus equals 1 to reduce the lives.
Okay, next, collision detection between player and the caterpillar using for and if. Remove the worm that hit the player using caterpillar rec and caterpillar remove. The reduced life. Background move using if. Background speed can be adjusted. If the background runs out, restart from the beginning. Image on screen using 2 screens. Caterpillar image using if. Image of the bullets on screen. Next, the score can be displayed in the right position, and also there is a live display. Next is the background update and frame rates. Thank you.